Hello everyone, welcome back to Year 2 Mathematics. My name is Victor and today we're going to be learning about a volume of cones, pyramids, and spheres. So prisms and cylinders have the exact same shape all the way through, like a loaf of and bread, but pyramids and cones do not. So they start with a fat base and taper up to a sharp point, and because they taper, they hold less volume than a prism of the same size. But how much less? So as you can see right here, I have a cylinder. So let's point that right there. So imagine a cylinder. Imagine drawing a cone perfectly inside it, sharing the exact same circular base, but with the exact same height. Now, how much of the cylinder does the cone fill? And so the ancient Greeks, basically the nerds, proved that the cone fills exactly 1/3 of the cylinder. So, and this is going to be a universal mathematical law. Priority shapes are always 1/3 of the volume of the straight equivalence, as you can see right here. So, as I have written right here, I have the volume of the cylinder is the area of the base times height. And so the volume of the cone is 1/3 times the area of the base times the height. So 1/3 of pi pi r squared h. And if you notice the h right here, the true vertical height for volume, in the last video I actually talked about how the surface area needed the slanted edge, which is the slanted height, but volume calculates internal capacity, so we need to use the true vertical height. So we're using h, not s here, dropping straight down from the tip and to the floor here. So the same rule applies for pyramids as well. So as you can see, here's a square-based pyramid. The base is 4 by 4, and the true vertical height is 9. It's a little bit, not very drawn out very well, but again, please be patient with. Okay, so volume here is going to be 1/3 of the time, 1/3 times area of base times height, as usual for the pyramid. So we can write that out. So let's just say, for example, we have V here. It's going to be 1/3 of times 4 times 4. We're taking numbers from here, and we're taking 9 here. And that should be 1/3 of 16 by 9. And this should give us 48 centimeters, not squared, cubed, because we are finding the volume, as you can see right there. So cubic meters. And lastly, for the sphere, as you can see down here, this is going to be the most complex shape. Its volume formula is 4/3. Okay, 4/3 times pi r cubed. Okay, 4/3 times r cubed. Notice that it's r cubed, not squared, because volume is going to be 3D. Okay, 3D. I believe that I've written 2/3 here, so it's actually 4/3. Sorry for that. So let's just say, for example, that we need to find a volume of a sphere with the radius of 3. So r equals 3. So to solve that, we just need to write our formulas as usual with these shapes. So we have 4/3 of pi r cubed. And this should give us, we need to substitute r into 3 here. So this should be 4/3 of pi in 3 cubed. So this should be 4/3 of pi multiplied by 27. And this should give me, let me just write that out for, this should be pi, this should be 9, so this should be 36 pi. And this should be roughly 113.1 cubic meters, so centimeters cubed right there, okay? And to top it all off, let's just repeat our habits. We have today's habits: whenever an object tapers to a single point, as you can see right there, here as well. Remember that pointy shapes here, always 1/3 of the normal volume formula, and always remember to use the true vertical height, not the slanted height. Use h for volume, okay? I'll see you next time in the next video.